In this video, we're going to practice writing net ionic equations. A net ionic equation captures the reaction of interest in a reaction that occurs in solution. We're looking for cases where reactants change state when they go to products. For instance, aqueous going to liquid or aqueous going to solid. Here's the process. You want to start by writing a balanced chemical equation with indicators of state. You'll need to use the solubility rules to determine if different salts are soluble or solid. There's a video up today that goes through the solubility rules and has a really neat flowchart for how to use them. Once you have that balanced equation, you want to separate all the compounds into their component ions and list their states next to them. Next, you will cross out any ions that don't change states from reactants to products. These are called the spectator ions because they don't really participate in the process of the reaction. Therefore, we can ignore them. You will then rewrite your net ionic equation using only the ions that change state. The reactants will still be dissociated ions, but the products will be associated compounds. Let's see this in action. Write a net ionic equation for the reaction of potassium hydroxide with acetic acid. So first we need to write a balanced equation for this. KOH is potassium hydroxide. Acetic acid is CH3COOH. And that's going to form water because a neutralization always has one product, water, and then the leftover ions from the acid and the base. In this case, it's going to be potassium acetate. Now we need to assign states. If you need more work on that, go check out the solubilities rule video. Potassium hydroxide has an alkali metal cation, so it's soluble. And acetic acid is generally water soluble. You can remember this because this is the acid that's in vinegar, and vinegar is a nice aqueous solution. Water is always going to be a liquid in these sorts of reactions, and potassium acetate has that alkali metal cation, so it too is aqueous. Our second step is we want to break this up into the component ions. So K plus aqueous plus OH minus aqueous plus acetate aqueous plus H plus aqueous will go to H plus liquid plus OH minus liquid plus acetate aqueous plus potassium aqueous. Now we're just going to compare the ions on each side, and we're going to cross out the ones that don't change state. That'll be the potassium and the acetate. They stay aqueous on both the reactants and products side. Now we're going to rewrite this equation using just the ions that are left. H plus aqueous plus OH minus aqueous goes to H2O liquid. Remember, the reactant side will have the dissociated ions. The product side will have the associated compound. This is our net ionic equation. Our spectator ions are the potassium and the acetate because they did not change states. Now it's good to note that the production of water is always the net ionic equation of a neutralization reaction. Similarly, for a precipitation, the net ionic equation will always be the formation of the precipitate. I'll see you guys on Friday.